The most significant data point regarding interstellar object 3I Atlas isn't something we detected with our billion-dollar telescope arrays or captured through sophisticated spectrographic analysis. It's something we measured with a simple thermometer. 0.7 Kelvin. That's the temperature increase recorded across the object's surface during a 6-hour window on October 17, 2025. Under ordinary circumstances, this would register as unremarkable background noise. Thermal fluctuations occur naturally when sunlight strikes rotating celestial bodies, except this fluctuation wasn't random scatter, it was synchronized, repeating in discrete pulses, directional, moving across the surface in patterns that don't match solar heating models or any natural thermodynamic process we've documented across 3 centuries of astronomical observation. When something 412 meters long, drifting through our solar system at 17 kilometers per second, suddenly begins generating organized thermal signatures after 3 years of dormancy, scientists don't typically use words like activation. That terminology carries implications, suggests intentionality, implies design. Yet, here we stand, watching temperature gradients ripple across an object's surface like waves moving through circuitry. And the scientific community has grown remarkably quiet about what this might actually mean. For nearly 3 years, 3I Atlas has compiled what I'd characterize as an extraordinarily strange dossier of impossible behaviors, perfect rotational stability where chaotic tumbling should exist, density measurements suggesting the interior is almost entirely hollow, deceleration events occurring in controlled bursts without visible propellant exhaust, every characteristic individually explainable through creative theoretical gymnastics, but collectively they form a pattern that resists natural interpretation. And now we have thermal activation occurring precisely as the object approaches perihelion, that critical moment when it passes closest to our sunday. The timing isn't coincidental. The pattern isn't random. Something inside that object is responding to environmental conditions, which forces us to confront a question the scientific establishment has carefully avoided articulating in public forums. What if 3I Atlas isn't a natural object? What if it's a machine? Not just any machine, a ghost ship. An autonomous probe launched millions of years ago by a civilization that may no longer exist, still operational, still executing its mission parameters, still gathering data, and possibly, just possibly, responding to detection of our electromagnetic signatures bleeding into space for the past 90 years. This isn't speculation anymore. This is observation. And observation demands we separate what we absolutely know from what we deeply fear. Now, before our imaginations venture toward exotic conclusions, let's establish exactly what the observational record actually documents. Let's be forensic. Let's be disciplined. Let's examine the evidence without allowing either wishful thinking or reflexive skepticism to corrupt our analysis. 3I Atlas entered our solar system in August 2022 from a trajectory originating beyond the heliopause. Its hyperbolic orbital path immediately classified it as interstellar, only the 3rd confirmed object from outside our solar neighborhood ever detected. Initial spectroscopic analysis suggested ordinary composition, carbon-based compounds, silicate structures, water ice. Nothing immediately anomalous appeared in those preliminary measurements. Then the rotation data arrived. Natural asteroids tumble chaotically. Gravitational torque from the sun, ancient collision impacts, asymmetric mass distribution, all these forces produce wobble. Every asteroid humanity has tracked exhibits this characteristic instability. Statistical analysis of over 14,000 cataloged objects confirms tumbling as universal behavior among natural celestial bodies. Except 3I Atlas maintains perfect rotational stability, 8.2 hours per cycle, 14 months of continuous observation, deviation less than 0.03 degrees. That's not statistical anomaly. That's controlled behavior. That's gyroscopic stabilization. That's engineering. The density measurements produced even stranger results. Spectroscopic analysis combined with gravitational influence, calculations yielded 0.18 grams per cubic centimeter. For reference, water measures 1 gram per cubic centimeter. Styrofoam measures 0.053. iAtlas registers somewhere between foam and cork. At 412 meters length, this density implies the interior volume is 93% empty space. Hollow, chambered, compartmentalized. Natural asteroids don't grow hollow interiors unless they're rubble piles held together by weak gravitational binding. But rubble piles tumble violently. They don't maintain gyroscopic stability. Then came the deceleration events. March 2024. Over 6 weeks, the object's velocity decreased by 0.4 meters per second. Not continuously, not gradually, in 3 discrete pulses, each lasting approximately 19 hours. Then complete cessation. The standard explanation involves outgassing from sublimating subsurface ice deposits, creating thrust. Except comets vent continuously when heated. They don't fire in controlled bursts. They don't activate and deactivate with temporal precision. They don't behave like maneuvering thrusters. By September 2024, astronomers at the European Southern Observatory conducted high-resolution spectrographic sweeps looking for chemical composition signatures. The reflected light contained periodic absorption anomalies at 127-meter intervals along the object's longitudinal axis. Not random variations, geometric regularity, density fluctuations suggesting compartmentalized internal architecture, hollow chambers separated by denser structural elements. One researcher described the pattern as modular. Another used the term segmented. The word nobody, published in peer-reviewed journals, was manufactured. The thermal anomalies began appearing 6 weeks later. Infrared sensors detected localized temperature variations shifting across the surface in 12-hour cycles. Not solar heating patterns, internal heat migration, something circulating inside that hollow structure, moving, redistributing, activating. And this brings us to October 17th. The thermal spike, 0.7 Kelvin increase over 6 hours, synchronized pulses, repeating patterns, directional flow across specific surface regions, occurring exactly 3 weeks before perihelion passage, occurring as electromagnetic radiation from Earth becomes increasingly detectable at the object's position, occurring as if something dormant just received its wake-up signal. If 3 iAtlas is behaving like a machine, then we need to understand what kind of machine makes sense in this context. And that requires examining theoretical frameworks developed by scientists who spent decades contemplating how advanced civilizations might explore the galaxy without faster-than-light travel capabilities. In 1948, mathematician John von Neumann described self-replicating autonomous systems. The concept was elegant. If you want to explore the galaxy but can't exceed light speed, you don't send biological explorers who age and die. You send machines programmed to replicate. Each probe reaches a star system, gathers raw materials, constructs copies of itself, sends those copies to adjacent systems. The exponential mathematics are staggering. Von Neumann calculated that even at sublight velocities, a single self-replicating probe could thoroughly map our entire galaxy in less than 10 million years. That's rapid time frame in cosmic terms. That's geological eye blink compared to the 13.8 billion year age of the universe. The strategic advantage of autonomous exploration systems becomes obvious when you consider temporal scales. Biological civilizations might persist for 10,000 years, perhaps 100,000 if extraordinarily fortunate. But machines don't age, don't forget their programming, don't require life support infrastructure. A von Neumann probe launched 1 million years ago could still function perfectly today. 10 million years ago, 100 million years ago, long after its creators evolved into something unrecognizable or went extinct entirely. Civilizations are temporary phenomena. Technology persists. Now, Consider Earth's electromagnetic signature. We've been inadvertently broadcasting our presence since the 1930s. Radio transmissions, television signals, military radar installations. Every electromagnetic pulse we've generated has propagated outward at light speed, forming an expanding sphere of artificial noise, currently 93 light-years in diameter. That bubble encompasses over 2,000 star systems. We assume we're invisible. We assume nobody's listening. We assume the universe hasn't noticed our recent emergence into technological adolescence. But a sufficiently sophisticated probe wouldn't need to intercept our entertainment broadcasts to detect technological civilization. It would analyze atmospheric composition for industrial pollutants, detect spectral signatures of artificial lighting on the night side of planets, measure radio frequency leakage from satellite constellations. All of these constitute what astronomers call techno-signatures. All of them are detectable from interstellar distances with appropriate instrumentation. 3. IATLAS entered our solar system at 17 kilometers per second along a trajectory aligned within 3 degrees of Earth's orbital plane. That's not random scatter. That's targeted approach geometry. It's now moving toward perihelion, closest point to our Sun, which occurs November 9th, 2025. And its thermal emissions have increased 12% since June. The rate of increase is accelerating. If this is a probe, then its mission profile likely includes proximity triggers. Detect habitable planet exhibiting techno-signatures. Approach parent star for optimal observation geometry. Activate surveillance systems. Begin data collection protocols. Prepare for potential deployment of secondary reconnaissance units. The ghost ship scenario isn't science fiction. It's applied probability theory. We've already built primitive versions ourselves. Voyager 1 and Voyager 2, launched 1977, now drift through interstellar space carrying golden records encoded with Earth's location and biological information. Both spacecraft will continue traveling for millions of years after humanity no longer exists to remember building them. There are ghost ships. Autonomous machines executing their programming long after their creators are gone. Now imagine encountering someone else's Voyager. Not a message, not a signal, just an abandoned machine, still operational, still recording, launched by a civilization that vanished 1 million years before humans evolved language. That's the ghost ship theory, not hostile invasion, not deliberate contact, just archaeological discovery, mechanical relic, orphan technology, still executing mission parameters because nobody ever transmitted shutdown commands. But here's what makes this scenario profoundly unsettling. If 3I Atlas is a probe, if it's been observing us, if it detected our techno-signatures years ago, then it's not just recording data, it's making decisions. Activation sequences don't trigger randomly. They trigger when conditions are met, when mission parameters require response. When the probe determines that observation protocols need upgrading from passive monitoring to active reconnaissance, and we're about to lose our line of sight. November 9th, perihelion passage. For 72 hours, 3I Atlas will transit behind the Sun as viewed from Earth. Solar interference will blind our instruments. Electromagnetic radiation will overwhelm our sensors. We'll have no direct observational capacity during those 3 days. Astronomers call this the blackout window, and it represents the perfect deployment opportunity. If 3I Atlas is designed to release subprobes, smaller reconnaissance units, data collection satellites, now is when it would do it. Hidden from observation, shielded by solar radiation, undetectable until reacquisition on November 12th. We're not claiming this will happen. We're noting that conditions are optimal, strategic timing, maximum concealment, minimal risk of detection during deployment operations. When the object emerges from behind the Sun, we'll have brief window to reacquire tracking and conduct mass analysis. If fragments have separated, if secondary objects have deployed, gravitational measurements will reveal changes. But by then, deployment will be complete. By then, whatever was meant to happen will have already occurred. This is the uncertainty we're navigating now. This is the informational void we're trying to populate with measurement instead of speculation. Now, before our analysis ventures into alarmist territory, we need to examine the darker implications carefully, rationally, without panic, but without naive optimism either. Because if 3I Atlas is a probe, if it's autonomous, if it's been observing us, then we need to consider its operational logic. And that logic might not prioritize making friends. In 2008, science fiction author Liu Cixin published a novel called The Dark Forest. The premise was brutal game theory. The universe contains countless intelligent civilizations, but they're all hiding, maintaining strict electromagnetic silence. Why? Because revealing your location to unknown intelligences constitutes existential risk. If you detect another civilization, you face binary choice. Communicate and risk them viewing you as threat, or eliminate them preemptively before they can eliminate you. Strategic first strike doctrine at cosmic scale. This isn't fantasy. This is decision theory, the same mathematics that govern nuclear deterrence and preemptive military doctrine. If an advanced civilization builds autonomous probes and sends them across the galaxy, what mission parameters would they program? Seek out life, assess technological capability, determine threat level, report findings, and if necessary, neutralize potential competitors before they develop interstellar travel capability themselves. We're not claiming 3I Atlas is hostile. We're acknowledging we don't know. We don't know its mission parameters. We don't know its decision-making protocols. We don't know what conditions trigger defensive or offensive responses. We don't know if it views our electromagnetic broadcasts as interesting data or existential threat. What we know is that something 412 meters long is behaving like a machine, maintaining impossible stability, exhibiting internal architecture, executing controlled maneuvers, generating organized thermal signatures, approaching our sun with apparent intentionality. And we know that our current observational capacity is about to go dark for 72 hours during the most strategically significant moment of its entire trajectory through our system. The question we need to ask, carefully and rationally, is whether our presence changes its operational parameters. Whether detecting our technosignatures triggers protocols we don't understand. Whether activating systems now means preparing for mission objectives we can't predict. Because if this is a ghost ship, we are no longer just observers. We are now part of its data set. We are variables in its decision-making algorithms. We are potentially, unknowingly, triggering responses we don't comprehend. So what do we do? What can humanity do while navigating this extraordinary uncertainty? First, we maintain intellectual discipline. We resist temptation toward extremist interpretation. Not every thermal anomaly represents alien machinery. Not every observational gap constitutes governmental conspiracy. Science progresses through measurement, not through imagination. Second, we continue systematic observation without pause. We aim radio telescope arrays at hydrogen spectral line frequencies and listen. We deploy polarimetric instruments to maximum sensitivity. We conduct trajectory analysis with unprecedented precision. We measure mass distribution before and after perihelion passage. We look for fragmentation. We look for course corrections. We look for any deviation from purely gravitational mechanics. Third, we prepare ourselves psychologically for the reality that scientific revelation in our 21st century era might not resemble the triumphant press conference previous generations imagined. Contemporary discovery might manifest exactly as institutional hesitation, careful consultation between competing agencies, measured communication into global information ecosystem where raw data propagates faster than human comprehension, can contextualize it. People ask me whether this represents the transformative moment we've collectively anticipated for over a century. That pivotal instant when the night sky transitions from beautiful backdrop into mirror reflecting intelligence back at us. My response mirrors what I tell anxious students confronting equations, describing realms they'll never physically touch. We will achieve knowledge only as rapidly as rigorous analysis permits, and the universe refuses to accommodate our impatient human schedules. If what our instruments ultimately reveal proves ordinary, then this moment will dissolve into academic papers and conference presentations, eventually forgotten. But if the observations prove extraordinary, then what emerges next will represent the most carefully constructed sentence humanity has ever collectively assembled. Every word weighed for its implications, every phrase examined for its consequences. Until that revelation arrives, remember this fact. 3. I-Atlas has already accomplished something remarkable without transmitting single intentional signal. It has compelled the most powerful space agencies on our planet, institutions that normally compete fiercely over prestige and publication timing, into unprecedented observational focus. Not through formal communication, through the immense gravitational weight of shared uncertainty about what they're witnessing. October 17, 2025. Something inside interstellar object 3, I-Atlas activated. Thermal signatures began pulsing in organized patterns. Internal systems started circulating heat. Whatever was dormant for the 3 years we've been watching just woke up. And now we wait. We measure. We observe. We prepare for the possibility that when that object emerges from behind our sun on November 12th, we might discover that we're not alone in this galaxy, that we've never been alone, that autonomous machines have been drifting through the darkness for millions of years, watching, recording, waiting for civilizations to develop technology sophisticated enough to detect them back. The ghost ship theory isn't theory anymore. It's hypothesis supported by observational evidence. And evidence demands we take it seriously, carefully, rationally, without panic, but without dismissal either. Because if this is a machine, if someone built it, if it's still executing mission parameters after traveling for millions of years, then first contact isn't going to be a handshake. It's going to be recognition. Recognition that the universe is far older, far more populated, and far more carefully watched than we ever imagined. And we just became visible